Yeah, that's quite basic. What's the probability of getting a sum of 10 when you roll 2 dice of 6 sides? Wait, what? Am I retarded? What the fuck do you mean hint? There's no way to flip red 5, blue 5. Of course it went. No, oh. Pog. Raw. Some events aren't as likely. For example, the probability of some 2 dice roll. The sum of 2 dice rolls being 2. What? Testing. Holy shit. What the fuck? Testing. Hello? Hello? Okay. Hello, test. Hello, test. What the fuck? Saved. Men det sånne ting de ikke finner ut av engang, så det sånn. Oh, that's what I meant. Okay. Return to you. Like, interview. Det sånn test. Next stage is a 75-minute total to complete the test. 50 minutes to complete section 1, 30 minutes section 2, 30 minutes section 3. This must be completed in one sitting. Det på sånn tur til Sveits greier. Med et selskap så jobber for. So rich, ja. So we need to prep. Til Oslo om 1 time. Holy shit, Pog. Oslo S, ja. Jeg får dra videre til... Fuck, hva var det? Var det Hellas? Roma? Ja. Nice. Det blir episk. Ja, så... Deadline 16. juni. Så 6 dager. Så må prøve å preppe litt før jeg gjør den testen. For å prøve å øke sjansen litt. Powered by HackerRank. Oi, det et hint. Det er et stort hint. Det er et veldig stort hint, faktisk. This hacker. Fordi hvis den her er powered by HackerRank, så er det kanskje et programmeringsintervju. The focus on competitive programming challenges for both consumers and businesses. Developers compete by writing programs according to provided specifications. HackerRank be sold in a variety of programming languages, including Java, C++, PHP, Python. HackerRank categorizes most of the programming challenges into a number of core computer science domains. Kan jeg prøve på det litt? Lead code, quant interview questions. Okay. Det er kanskje det en bedre måte å preppe på. Example, the probability of the sum of two dice rolls being 2 different than the probability of it being 7. Okay. Something you care about has a 30% chance to be 0.2% chance to be 1, and 50% chance to be 2. You can imagine there are 10 equally likely events, 3 of which result in 0.2, of which result in 1, and 5 of which result in 2. Do you understand? For example, suppose there's something. Oh, I misread. I thought this at 0.2. This has 30% chance of being 0, 20% chance of being 1, 50% chance of being 2. You can imagine there are 10 equal events, 3 of which result in 0.0, 2 of which result in 1, 5 of which result in 2. Yeah, of course. Okay. Probabilities. Mathematics. Probability. Probability. Wait, what? I guess probability, maybe fundamentals. Probability is probably better. Okay, we'll try these ones, I guess. Oh. We already use probabilities, but before going further, we'd like to be more precise about this term. This helps us in turning problems where it's a little hard to simplify. Welcome back. Okay. Those of outcomes some everything. Okay. Probability of A or B is equal to the probability of. Does this make sense? Yeah. Probability of not A. Does this make sense? Something has to happen, and it can't be A. Okay, yeah, okay, that makes sense. So P or A is equal to 1 then. Okay. Independence. One issue that arises is that the set of possible outcomes can start to get large and widely. Oh. Difficult to manage. Okay. Yeah, that's okay. If I'm thinking about the set of possible outcomes for a set of 100 coin flips along with the weather tomorrow, then all heads with warm temperature is distinct from all heads with cool temperature. Okay. And concludes along with the weather tomorrow, then all heads with warm temperature. All heads with warm temperature is distinct with all heads from cool temperature is distinct from all heads except the last coin. Okay, this is like a dyslexia nightmare. If I'm thinking about the set of all possible outcomes for a set of 100 coin flips along with the weather tomorrow, all possible outcomes for a set, like, is the set the probability of 100 coin flips plus the set of weather tomorrow? Possible outcomes for a set of 100 coin flips with the weather tomorrow. I think that is it, right? Then all heads with warm temperature is distinct from all heads with cool temperature. Yes, okay, I get it. It's distinct from all heads except the last coin. And the temperature is warm. Okay, so basically, how can I make this nice? Text. There we go. That's cool. Okay, so basically, what the fuck? Guess we can go like this. So basically, P coin plus weather is equal to 1. and then basically P coin head plus weather and warm is equal to is less than 1. I guess it could be if we say that, okay, it's less than 1. But this is distinct from, this is like all heads, the function all heads, and then this is distinct from coin all heads minus 1 head plus weather warm. This does not equal that one above. So this is a distinct probability basically. Okay. It quickly becomes impractical to list all the outcomes very often, and very natural we want to break things up into smaller chunks that feel are unrelated to each other. In the coin plus weather example, we probably don't think either outcome is in any way affected by the result of the other. And moreover, each coin flip is probably unaffected by any other flip. The word we use to describe the situation is independence. Independence arises when probability of 2 outcomes are unrelated. A nice property of independent outcomes is that the probability of them both occurring is the same as the product of the probabilities of individuals occurring. Yes. But is it really? Yeah, that makes sense. So basically, if you have I guess we'll like this maybe. Probability coin plus weather is equal to 1. So if we have probability for coin I guess we're gonna go like 1 coin head is equal to 0.01. Probability of coin 2 is equal to heads. Then probability of coin 1 being head plus probability of coin 2 being head is equal to 0.01 times 0.01. I guess, right? But do I have all 3? Fuck. Well, oh yeah, that was stupid. Okay, so for PC1 plus C2 plus C3. Okay, so probably wrong to use plus, I guess. Okay, I'm gonna try the better example. Okay. So I guess with the probability of coin head, weather warm will be probability of coin head times probability of weather warm. So this is 0.5 times, let's say, 0.6. 0.3% chance. Okay. Okay, what is the probability you draw 2 face cards from a deck of cards if you put the first card back in before you draw a second card? So they're always independent. So how many face cards are there? There's 3 times 3, right? Yeah. No, 3 times 4, I mean. Probability face card. Face card, face card, face card. Because you reset every time. So this 0, no wait, this is 3 times 12 divided by 52 times 4. No. To the 4. Makes sense, right? Probability of one face card times itself, times itself, times itself. Yeah, I think that's correct. 3.053. Wasn't it 4 times? Because you draw 2 face cards from a deck of cards. Oh. That's stupid. go like this. 0.053, yes, okay. What's the probability that you draw 2 clubs from a deck of cards if you don't put the first card back from... Okay, so clubs will be 1/4 of the deck. But you don't put it back, so this will be times... wait, let's see here. Is it 14 times... let's see. 14 times 4. Is it 13? 13, 26, 40, 52. Yeah, it's 13 each. Okay. So this will be times 12 divided by 51. Yes. Right. Probability of clubs. Yes. Okay. So probability that the product of 2 rolls for 6-sided die is odd. 3 rolls. The product of 2 rolls. Okay, so it's 2 questions. First with 2 rolls, then with 3 rolls. Okay. What's the probability that the product? Oi. That's a bit more tricky, I feel like. Probability. Okay. Because now it wouldn't work anymore. Since if the first one is even, you have half a... it's 50%. But how would you show it? It's basically probability of odd, probability of even is one solution. I don't know what that was. So this will be 0.5 times 0.5. But you also have probability of even, then probability of odd. So we have 2 times this. That apparently didn't work. This is the probability. This is the only combination we have. I believe. So how would that work? Can you just sum them? I guess you can. But how would it show it in a nice way? This wouldn't really work. Basically, you have these solutions, right? But now we're just drawing it out, all the probabilities, so that's not efficient to be doing it. So for 3 rolls, this would suck. Let's think here. Good luck. Thank you. I'm probably cooked if I can't even do this. I know how to do it. I know the answer. But you should know like a general way of doing it, you know? How hard can it be? Because it's not independent. This is probability. This is a base theorem. Probability of A given B. Right? No, but that doesn't make sense because you have two solutions. Fuck. I know. Okay, that's good. If this is like just a lead out question with no good solution, I'm gonna be pissed. Wait, what does that mean? Okay, so this is the product, so that's a big difference. I misread it. The product. Is that like a general... No way. Is that a thing? But basically, you can't get an odd number with playing even. I can't think of an example where it's not the case, so that's probably true, I guess. Okay. So the probability of the product of two rolls being 6 is basically probability of odd times probability of odd, so on. So basically you have probability of odd, for example, would just be the probability of odds to the count, I guess. So 3. But we should probably understand the sum though. What if it was the sum? How would you find it? What was it? 12.5? Yeah, okay, that's great. Since the sum seems more difficult. Like, it doesn't seem like it has like a general solution in this way. I hate when ChatGPT doesn't format, it's annoying. I have probability of odd. times 1/2 times 2 probability of being even. What even is the issue here? T times frac 80. Basically probability of any odds given to even would then be 0.5 times 0.5 squared. That's a misunderstood. Write it again in a different. Should I come back to it? I think we come back to it because it's probably covered and probably covered in a better way. Often the set of outcomes you are considering can naturally have. Okay, wait, lunch first and then we'll continue. Right, look in. We got this. How difficult can it be, you know? Well, that's probably one of the most difficult jobs to get in the history of Northgate. Except for you know, the special positions. Random variables. Oh, yeah. Often the outcomes you are considering can naturally have numbers attached to them. For example, the number of pips. What the fuck is a pip? Die. Pips. What the fuck is a pip? Is that like those dots? Yeah. Okay. A set of outcomes you're considering can naturally have numbers such as the number of pips or price of a security in the future. What is a security? What is a security? As in fine. In finance, a security is any tradable financial instrument that represents some form of financial value. What is it called? Security. That feels like a strange name. Equity, stock, debt, contracts, okay, derivatives, contracts whose value is derived from another asset index rates. Okay, so securities are like foldable contracts, I guess. How much money you might make or lose as a result of some bet. If you associate a number with each possible outcome, you can think about the numerical value of the outcome, which is unknown as a random variable. Okay? Bro, I have no idea. They can't be, right? B as a variable and R as a variable is independent. Because being told the outcome of one never gives any information about the other. Is B plus R independent? We're saying that let X be B plus R is X independent. Then we're saying, oh, are we saying that B plus R is that independent from B times R? Is that true? B plus R will either give odd or even. So that will give information about the product as well. So if we know the sum, we know if the sum is odd, that means that the product is even. Okay, so we get some information, but not as much as you might think, right? But yeah, you basically have this distribution here. So if you get the number, you get some idea of where the product will be. And if you get an odd number, you know that the product will be even. And if you get an even number, you know that the product has a 50% chance of being odd. So you get some information. So they're dependent, I guess. That's my final answer. I'm gonna see what ChatGPT says. Yeah, basically, yeah. In fact, anything you can do with regular variables can also be done with random variables, given you new random variables. If you have the temperature in Fahrenheit as a random variable, Fahrenheit, but you want to think about it in Celsius, you can make the conversion, which is also a random variable, but okay. If you compute to work, if you commute to work, if your commute to work involves driving to the train station, then running to the train station, Jesus Christ. If your commute to work involves driving to the train station and then driving the train, then your total commute could be d plus t, okay? The average of a random variable is the most important single piece of information about the distribution. That's by far. Okay. Yeah, what the fuck is it? Is it small x or big X? That's small x, okay. Okay, so we sum up every probability the variable has, and we times that by, I guess you can call it outcome, maybe the value of the probability. The random variable x ends up being x. Okay. If some random variable, let's say car and road, that does maybe not make sense, but yes, will be 7. Then you times 7 by the probability of that. Let's say that's more than 200. Okay. Capitalize random variables to distinguish them from plain old variables. Okay, that's good to know. Note, you could have also obtained 3.5 by just taking to yourself what's the midpoint of the outcomes. That's because the distribution of both pips is symmetric around 3.5. That's not that intuitive to me, right? Is it? 1 plus 2 plus 3 is 6. 4 plus 5 plus 6 is 15. 1 plus 2 plus 3 plus 4 is 10. That's not intuitive at all to me. What if I would it be 3.5? I'm not getting the intuitive understanding here. The expected value of rolling a 6-sided die. 1 plus 2 plus 3 plus 4 plus 5 plus 6. 16, 19, 20, 22 divided by 6. 3.6. What the fuck? 1, 3, 6, 10, 15, 21. Oh. Help me intuitively understand what they mean by midpoint. Maybe graph it. Do you think this means that 6 occurs half as often, or half of the throws ends up being a 6? I think since it's reweighted, it's read that 6 occurs half of the time. Okay. Okay, so then that's not as simple. Because then you have basically you don't have damn, okay. It's a bit tricky. Because you no longer have as an expected value of die throw. What the fuck? So basically, for the 5 others, okay, so you have 1/2 times 1 in 5 for for 1 plus 2 plus 3 plus 4 plus 5 plus 1/2 times 6. I think that's my answer. Like intuitively it makes sense, at least. That's very cool to have this ability to just solve such problems. Bro, I really thought about doing that test yesterday evening. I think that would have been very stupid. Okay, what the fuck? Something went wrong. Fuck. Then just switch it. Okay, what the fuck? I guess we try to restart maybe. Okay, it's working. Okay. Cool. Let's just think about this for a bit. Expected value is the probability that value happens. Okay, it's the sum of the probability. Basically, it's the sum of the product between the probability that something happens and the result of it happening. Yeah, okay, I think that's what threw me off. Wait, was my formula wrong? No, that's correct. Yeah, so this is basically more like a probability distribution. Okay, I overthought it. Basically thought that since 3, 4, and 5 has a greater sum of die dots, the probability distribution would like have more dots, I guess, or pips. Still though, I feel like that's still the case. Expected values have lots of nice properties. For two random variables, x and y. No fucking way. Really? So, okay, so expected value of drawing one die, or the expected value of the sum of dice, I guess. No, these are not examples for what I asked for. I guess we're like... Oh. YouTube break. Scroll for like a few minutes.
Got me an ML degree.
Slight performance. Okay. Let X be fair die roll and Y be a fair coin flip. Yeah, okay. Expected value of die roll, expected value for coin flip. At least does not make sense to me. Really, can I do this? Can you? Really? What the fuck does this number even mean in this case? Verification. Possible X plus Y values. Y0, X plus Y, blah blah blah, Y1, blah blah blah. Expected value, sum for... Yes. Okay, I get the math that is fair, but like, what the fuck does this even mean? Okay, we'll try on this one ourselves. Okay. Draw 2 cards from a deck of 3 cards labeled 1, 2, 3 without replacing let. Okay. We can try the linear shortcut first, I guess. Without replacing. Can you just sum them? The expected value of the first card will be 2. Expected value of the second card, I guess it's still 2. Is it just 4? Or do you just... But it's without replacement. Ooh, I have no clue. Like, what the fuck? They're dependent, so it's like very different. I don't know. But without replacements, so how is this the case still? Since if this turns out to be a 1, the expected value of y is greater. I guess by symmetry it cancels out, but I don't see how you can tell that easily. 1 true. That's so fucking unintuitive, right? Why is that the case? DeepSeek, don't give up on me now. Come on. Could you explain why the expected value of two dependent variables for the last expected value second variable is unaffected by the result of the first? This is actually just this is the what the fuck, the goat on the car game. So basically you have expected value of a choice plus expected value of the second choice. So this will be EX plus EY. This is one case, or if you don't decide, you just have this one. Right? So this is 1 in 3 plus you get a new pick, which is 1 in 2. And this. Really? I thought it was like this is just 1 divided by 3. Road and car problem expected value of picking another door. .8. Is it not? Is this the same as 2/3? It's not, but what the fuck? Whoa. Why is this not the same? It should be the case. It has to be the case. Okay, so this isn't the case. This is okay. This does make sense because it's not one thing. Basically, have expected value of X, then expected value of expected value of Y, I think. Does it make more sense? Nope. Fair. Is the product how you would Monty problem? Expected value of X, Y, expected value of X, expected value of Y. No. Now we're in really fucking goofy math territory. Like seriously, I can't take this test before this is like stuck in my brain and like, oh fuck. We're back to school, baby. Oh, this is gonna be so difficult to learn well. And also when ChatGPT is fucking having a difficult time, fuck me. Pose. Bro, I'm getting fat, fuck me. I'm saying as I eat a fucking cup noodles. Smart. So this will be when they're dependent, then I guess. Okay, right. The test has to be taken 16th of June. 16th June. 6:59 p.m. UT to Central European Time. EDT 6. So that's basically 7 p.m. Right? Yes. So that's Wednesday. On AM. Wednesday? Oh, wait, no. So, if this is the 10th, this will be the day after, basically. So 16th, 17th, basically. Sixteenth of June, 2025. Okay, so basically by this evening. So, okay, basically, if the outcome of a first die, second die, since dies are independent, basically it's asking what's the expected value of the product between two die rolls, basically, I think. So that's 136 then. Oh no, expected value is not the same as the chance of one outcome. Fuck me. Okay, so it's 3.5 times 3.5. 75? What? Am I stupid? 3.5. Didn't I just say 75? Maybe I said 35. Okay, so I just mistyped, I guess. Okay. Okay. Okay, let's see here. Can use the linearity, I guess. The expected value of the product between two die rolls. We basically need to show that this is equal to this. Right, okay, so expected value x times y will be expected value of x. Wait, x times y, x times y. What the fuck does that even mean? Oh, we're actually just doing that. Okay. Wait, what? X times Y. What the fuck is X? The probability of one. Sum. I guess this is all probabilities. So this is just. This is just. What the fuck? I don't get it. I can get like 1 in 36 chance of anything happening. 1 in 36 chance of. One 36 chance of getting. Explain how. To compute X times Y for two independent paired dice. I just want to see one question. Wait, what? Are all this just programming? I guess. Okay, so this is 1 times 1. Is it? Okay, 0. Is it starting at 1 going to 6? Okay, so for I in range 1 to 7, for j in range 1 to 7, fuck, I should use a sum first. Sum for what do you mean print? Is okay. I guess some is a used variable, okay. Okay. Does this make sense, or? So this will be yeah, 21 times 21. Yeah. Okay. Okay, so basically you have a sum of all values. So this will be basically 21 divided by 36, I think. No. Divided by 6, I mean. 21 divided by 6. Yes. But now you basically have 21 squared divided by 36. And 6 times 6. 12. Yes. Okay. So this is basically okay. basically the sum of all results you can have divided by. Okay, sum of results divided by chance of each. So basically, if we have a skewed die roll, right, the sum of results will still be for 1. But if we say that, no, that wouldn't work. Okay. The first one is fair. Okay. Okay, the first die roll is fair. So this will be the sum divided by chance. But the second one is not fair. The second one is, it has half the chance of being having 1 to 5. Then half the chance it will be half the chance it will be 1, 2, 3, 4, 5. Then half the chance it will be 6. And this we divide by 6. So this is basically the first dice is random. The second dice, to make sure this is correct here. I think so, yeah. The second dice, the first 5 has a 1 in 10 chance each. And the 6 side has half probability. I think that's correct. So this, maybe not actually. No, it has to be. It has to be. So basically we expect the sum to increase. So maybe we expect something like an expected value of 30, 40 maybe. Maybe I mistyped. We can try. Six times. Is it not? Yes, of course. 21 divided by 6 is correct. This is not correct. The sum of probabilities is the chance of something happening times the chance of it happening. Am I stupid? All outcomes. So basically this 21 will be 1 divided by 6. We can see. 1 divided by 6 times 1 plus 2 plus 3 plus 4 plus 5 plus 6. Yes. So this second one, oh, I'm splitting it up already. Okay, so this would be like this then. Okay, there we go. I think. So basically, the expected value of the other one would be this. Yes, that's correct. Yes. Okay. Or you could basically just split it up, so you have expected value for the first one times the expected value of the second one. So this will be damn, this shit is difficult and very unintuitive. Okay. Yeah, okay, so this will basically be 3.5 times 3.5. Yeah, okay. How come? What's it? I think I'm about to. Okay, we finished this chapter. But holy shit, my brain is like completely fucking clueless. Okay, I'm not clueless. Like. But Jesus Christ. There's so much new information here. How the fuck would that. If with A be the event that you win the bet. And you get paid X if you win and Y if you lose. Y is probably negative. Okay. Then your payout is Y times like I don't understand this notation as well. What do you think the average amount of hours programmed person with a master's degree in CSS? Okay, we make that after. We make a total hours programmed. That could be cool. That could actually be very cool. Okay, that's the plan when we were finished with expected value. Suppose you place a bet, event A, your team wins. So you put the value function 1A to basically 1 times the probability of winning. Get paid if a payout can be written as chance we win minus plus or expected value of win plus expected value of lose. No, that's not. That's payout. No, yes? Is that the case? Expected value is that payout? I guess that is. So if you have a 50-50 chance of 1 and 0, your expected payout is half of what you bet. No. Bro, this math is so fucking confusing. 1 if we win payout X, lose payout Y. Okay. I guess this is without. You win 100 half the time, and you lose 100 half the time. Yes. You win 100 0.7% of the time, and you lose 50 0.3% of the time. Yes. Okay. Let's try to think through that ourselves. Oh. Jesus fucking Maybe I'm not built for this. Maybe I'm not. It feels like there's this whole new part of my brain that's never been used. It has no like grappling points or whatever you would call it. So it feels like this is like a not even a whole new language, but because that wouldn't even work. It just feels like it's like a whole new field of study. This is not math. I guess we can read this again, maybe. Okay, we take a break, do something else, and then we come back to this. And hopefully my brain has rewired itself a bit. We can try this, I guess. I wonder if oh, Camel is not here. Okay, so like go like this. Okay, I guess that works. Okay. X is a normally distributed variable with a mean and a standard deviation. Okay, I don't know what that means. That's sigma, right? Good luck on the intro. Thank you. What? Of course. You took some coffee? Ah, the interview is... Oh, it's not even an interview, it's like a test. And it's has to be done in less than 6 days. So I'm just gonna study for a few days. Base.go of the Sigma mail. Thank you. The superior browser. I don't want that learn. I want standard Google answers. I want to learn the browser, not the browser to learn me, you know. Okay. So I understand this stuff. Start sluxing. I've never seen this in my life. Okay. So, okay, basically. Sort of interrupting, no worries. I'm guessing this. Oh, there it says mean. Okay, so the mean is just the value it's hovering around, and the standard deviation is the size of each block. Okay. Balance point, spread. So sigma being 4, I guess, so 34, 38, 32, no, 42. Okay, I think I get it. Find, I guess, the probability that x is less than 40. Okay. Okay. So this is x. Answer 1. I don't think I have the math still. We have a distribution of values. We need to convert that to probability. How do you... oh, it says right there. About 68% of values lie within 1 standard deviation of the mean. Okay. Okay, so we basically say that all the values would be 100. 68, so this would be, I guess we'll do 100 times I'm not sure. Okay, we'll take an example. Say x is equal to 34. That would be a bit above the curve. That would be at 1 standard deviation actually. So this would be the probability would be 68 then, I guess. Damn, I don't know. Is this just hard coded in? Empirical? About? How do I convert between them? Probability of being more than 1 standard deviation above the mean is about. How would you actually compute the probability given some distribution? Oh, we can try to figure it out ourselves, I guess. We try for a bit first. A fair is almost just. A fair is actually just defined as something probably. Okay. Gaussian distribution sucks. Does it? If you know, could you give me a hint? If you're giving the parameters of a distribution, how would you compute the probability given a value? Don't say the solution if you know it, just like a small hint. Is it just by definition? Gotta go. Time being, time to work. Take care. Thank you. You too. It seems like it's just by definition. But there has to be some function for it, right? Probability distribution. No, but the probability distribution is created by the dataset. Right? Is it asking for exact values or? Find probability of x being less than. I don't think it's asking. Wait, what? I don't think it's asking for anything. This is just hard-coded, right? It says read from input, but I don't think it does. Since NEX wouldn't make sense here. I think it's just asking to count up. What? Can I just hardcode this in? We don't use X, we just say that A will be 30 is the base, so this is less than 40 would be 68. I think this is 68 plus 13 plus half. This is just half, so this is 2.1. Can't be. This is 0. What was it? 2.1 79 97 971 979 21182, yeah. Greater than 21. 50. I feel like this is not how you're supposed to do it. Okay, that's not even that fun. Let's just look up table. I don't know. Let's ask, I guess. Nine and 4. This is the probability of X given the normal distribution. Is it? This can't be. This is wrong. What? Probability of pin. Oh wait, nah, that's correct. Never mind. Okay. Look up or compute. Earth. What the fuck is Earth? Error function. Oh, this like if 0 ignore type of thing. was right earlier. It returns an error function of a number. The method accepts a value between. Wait, what? Okay, I don't understand what it does. Is the error function like at the error? Is that like a specific function? In mathematics? Oh, it is? Oh, okay. 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 So basically, how the fuck would I have known this? What's the actual solution to just look up the answers? Okay, what? Okay, so that's a stupid one, I guess. 78% success rate? How? Can you see like submissions? There's no way people know this stuff. They must be cheating, right? Or are they taking like... You can Google stuff. I guess we'll try an easy one instead then. Birthday gift. I don't want to read all that. I want to read all that. Isaac has to buy a new hacker phone for his girlfriend, Amy. He's exploring the shops in the town to compare the prices, whereupon he finds a shop located on the first floor of the building. Okay. That has a unique pricing policy. There are n steps leading to the shops, and numbered ball is placed on each of the steps. A numbered ball. The shopkeeper gives Isaac a fair coin and asks him to toss the coin before climbing each step. Fair coin. If the result of the toss is heads, Isaac should pick up the ball, else leave it and proceed to next step. He should pick up the ball. Okay. A shopkeeper then asks Isaac to find the sum of the numbers. Sum of all the numbers he has picked up, let's say S. The price of the hacker phone is then the expected value of S. Help Isaac find the price of the hacker phone. Input format to the first line of the input contains an integer n. Number of steps. N lines follow. Okay, I guess it's each. So basically 4. And then you have the number on the ball or something. Which of the numbers? No, okay, the first line of the input contains an integer n, the number of steps. End line follow. Okay, so 3, 1, 2, 3, and then the number on the ball. Okay, okay. Output format: a single line containing expected value. Fair. Note: expected value must be printed as a decimal number, having exactly 1 digit after decimal. It is guaranteed that the correct answer will have at most 1 digit after decimal. This is print for us. Complete solve function below. The function is expecting to return a double. Functions into the array balls as okay. So I guess we basically print out. But how do we do this again? I guess we can go like this. Value. So basically answer dot. Oh. Okay. Not IMAP. Hello. Okay, I can't use Vim without my key bindings. Okay. So n equals 0. Why is that an error? Oh, okay. And then I guess we call values is balls starting at 1 going out, I think. That's correct, no? 1 everything after. I think so, yeah. Okay, let's see. The end steps leading to the shop. What's the value range of n? Of the ball, I mean. Okay, so okay, values is the okay. I'm understanding. S are values on each. Okay. So we want okay. Each step has an expected value for S in values. This is not S. I can call it small s, I guess. I guess we'll call this X actually. Expected value of S should be plus equals 0.5 times the value of X. Okay. How do we get n if we have the length of the list? Is it more? Why would we have n? The first line of the input contains integer n, the number of steps. N lines follow. Which are the numbers given written on the ball in each step? Output a single line containing the expected value. I guess we don't really care about n. I don't know why we have n. I think it's great. The expected value is the sum, or is basically each times the probability, and the same probability on each. So this is the sum of all the values divided by the probability of picking up a coin, so it's half. Yeah, I think that's correct. Double check. First one is balls. Values would be from 1 out. Should this be from 0 maybe? I guess we can try. Ah, that sucks. 3, 1, 1, 2. What's my output? Input, expected output. None. I guess this doesn't count. I guess it's printing out for us, maybe. Okay. The expected value would be the probability of 1 times the sum. Yes. So this is correct. I guess this could be the mistake. Okay. So list slicing. This goes from the first one but skips it. Okay. Nice. So small misunderstanding in the Python syntax error, but the correct answer. That's cool. Okay, let's try another one. I want an easy one. There was only one easy one. My bad, my bad. Nice job with the physics as well, but I don't know Python yet. Good luck on your interview. Thank you, thank you. Again, it's not really an interview, it's like a test, rather. And it's not really a job, it's a work visit. But it's still cool. I think this might actually be possibly the highest yield 5 days I could possibly have in my life ever. And I just need to keep telling myself that to work more, because it feels like so chill now because you're done with school and nothing to do and all that, but if I do well on the test and do well on the interview and get this summer or like the autumn camp, I guess, that would completely change the trajectory. How the fuck do you say that? The trajectory of my life, I guess. And it's like 5 days now with hard work would probably, I would guess, okay. Since we worked so much on probability today, we can actually use it. Okay, let's say my probability of not getting in, my standard probability if I didn't do any work would be let's think. So this is just half. Okay, basically, how many get to interview? How many is applied? You would think. So pass initial screening. And this test, I'm guessing it's a bit hard to grade, and there's probably not that many people grading. So maybe not more than 100 people taking this test. And I don't think they want to do interviews with 50 people. So maybe they will try to get... Oh, okay, yeah. I can see interview with 50 people. What's that? Like... So I can do 10 a day? I don't think I can do 10 a day. 5 a day? 10 days? 2 weeks for the interviews? For summer camp? 2 weeks of job? No. Damn, I have no idea. I have absolutely no idea. I guess we basically, okay. Let's say 50 apply. Let's say stand probability is 50 divided by 200. 200 takes the test. 50 people move on. I feel like that's on the higher end. Okay, fair. Then P with practice. Are probabilities additive? Since now I'm not really using probabilities, I'm just pulling shit out of my ass, I guess. Okay, let's say I practice hard and can get 1/2. So I go from 1/4 of getting it to 1/2. Then there's the interview process that I don't really think I can do much with. So let's say that probability interview will be 3/4 move on. 3/4 get the summer camp. Okay, so now my probability of getting in. Maybe I didn't practice enough. Would be the sum of probabilities. Okay, so this would be print no prac would be Pn times, there's a comma here, I think. Pn times Pi. And then we do a comma, new line with prac would be P practice times P pi. Without. Does this look correct? I think so. Okay. So what's my probability of being accepted? Okay. So I go from 18% to 37. So that's a big difference. And I feel like those are bad estimates as well. Let's say Pn is actually 1/2. And now let's say P is 3/4. This is the better end, I guess. What's the probability then? So 50% chance of getting in with practice. I think that's good. Okay. So that's why. Okay. There's an ideal random number generator which gives a positive integer m, which given a positive integer m can generate any real number between 0 and m. Is this what? Wait, what? Are we actually returning like this thing? Okay, we're returning the string, okay. I don't think I can solve this actually. There's a lot of stuff I don't know here, I think. Given two numbers and b, is this supposed to be m? No, okay, C is given like this, okay. Yeah, I don't think I can do this actually. Yeah, I don't know. Yeah, I give up. Yeah, there's no fucking way I could do this. Never guaranteed success. Yeah, I don't know. People are supposed to do this. I really have to like. There's no fucking way people do it. Like, do this without Google, right? Think of coordinate system XY, draw a triangle of width A and height B. Set the bottom left of the rectangle as the origin. So the bottom left, okay. Any combination of A and B that sum up to C can be expressed as by the line. Yeah, C is also in a triangle. Okay, fair. The question becomes how to find the area under this curve that overlaps with the area of the rectangle. How to find the area of this curve that overlaps with the area of the triangle. I don't know why it's squared. Is that something with the... Oh, no way. No way. Does that work? No, that can't work. No. I don't know. Yeah, there's no fucking way. There's like 7 different math subjects I miss to be able to figure that out myself. Okay, maybe not, but you know. We can try with months, I guess. handshake. Do you want to read that? Okay. Handshakes has exactly one time with everyone. Tell me how many handshake is there. This is easy. This is like n factorial. Do we have like mat factorial? Yes. N function is pictured as an integer. The function accepts an integer n as parameter. Is there more to it? Wait, what? Complete the handshake function in the editor below. Handshakes has the following parameter and the number of attendees. The first line contains the number of test cases. So that's not necessary for us, I guess. Each of the following t's listed contains an integer n. The function is expected to return an integer. The function accepts an integer n as parameter. Is it just mistyped or something? I guess we can try. Is it n-1? 2 people 1. 3 people 1, 2, 3. So that's 2. Yeah, it seems like it. Okay, so if n equal, I guess, less than n is between 1. Okay, if n is equal to 1, return 0. Else mat factorial n minus 1. Nice. Not nice. Runtime error. Yes, that makes sense. Okay. What's the deal here? I think we create a map, right? A lookup table. Is there a lookup table we can use? A counter object. Why isn't mat factorial optimized? Like, if mat factorial isn't optimized, how the fuck am I supposed to make it quicker? I guess if the test case loops, we can like save it. So we can go like scene. But this would only work in like very special cases. I don't think it does, but we're gonna see. By scene. If n in scene returns scene n, else scene n is equal to this. We could try this, I guess. Return scene n. Rip. What's the timeout error? Runtime. Okay. So it could be correct, just the runtime. Okay. Wait, this is wrong. My code is wrong. Is it not factorial? It has to be, right? Oh, it's not. It's not. It's the count of the sum, basically. So okay, so this is not wrong. This is not correct. I mean, this is basically from n plus 1 to 1 minus 1. Really? What? Two. 3 plus 2. Oh, that takes care of it. Okay. 1 to 1 is 1. Answer. I guess this works. One guess should be 0, 2 guess should be 1, 3 guess should be 2. Okay. Alright, let's try explaining it out loud, it might help. Yes, I get it. That's a good point. So we want to sum up all the guests, basically. So if we have 6 guests, we want to have basically the 6th guess will have 5 handshakes. So the other one left will have 4 handshakes, 3 handshakes, 2 handshakes, and so on. Which means if we have 6th guess, we want to sum everything from n to 0 maybe. So this will be 6, this will be 5, plus 4, plus 3, plus 2, plus... No, this is from 2, not including. So this will be 6 plus, so this is wrong. This is 6 minus, so this is 5, 4, 3, 2, 1. So it didn't include 1, so that's, okay. Okay, I think that makes sense now. I guess we can try the lookup table as well. I don't know if it's needed now, that it's just summing. If n in scene returns scene, and there you go, congrats, thank you, thank you. Else scene n is equal to answer. Okay. Nice. Cool. Yeah, that was tricky. Since I am usually in range, I thought the smallest number would be included, but not up to the biggest. But that's not the case. In range is the first one that it's starting at, going to the last one, but not including. So when we're looping backwards, it will start at the biggest, but not go to the smallest, which threw me off a bit. I guess this technically would work the other way around as well, though. So this, we can actually just go like, this would be 1 to n would actually work as well, I think. Yes. That's less intuitive because you don't get the sum of guessed decreasing as everyone has shaken hands. But it's the same mathematically. So yeah, okay, cool. Connecting towns maybe? Oh, that's a little text. Do we have time? Yeah. Do we have time? 7. Okay, I think maybe not, since I need to... Okay, wait, one more, then I go. Cities on the map are connected by number of roads. The number of roads between each city has... the number of roads between each city is an array, and city 0 is the starting location. The number of roads from city 0 to 1 is the first value in the array. From city 1 to city 2 is the second, and so on. How many paths are there from city 0 to the last city in the list? Modulo. What's modulo? That's the remainder or something, isn't it? Yes, that's the remainder thing. I think. Yes, okay. There are 3 roads to city 1, 4 to city 2, and 5 to city 3. The number of total roads. What? What's the thing with this thing? We're saying if the roads are greater than this. Is this for like solution purposes or something? I don't know why this is a thing. So basically we return answer modulo 1 2, 3, 4, 5, 6, 7, I think. So basically, if answer exceeds this, the answer becomes the remainder for some reason. Okay. If I understood it correctly. Okay. But all the towns T I for I is equal to 1, 2, and... Bro, how the fuck did 84% of people bother to even read this? Complete the connecting towns function in the editor below. Number of towns. Bro, I already forgot what the question was about. What the fuck is this input? You have 2 test cases, 3 with this, 4 with this. The expected to return integer. I don't get it. Is it saying that the route's first input... No, I think it's actually doing the conversion for us, so we don't care about it, actually. So 3 will be the integer, 1, 2, 3 will be the routes, I'm guessing. Number of towns. The second connecting space improvement. The number of routes from town T1 to T. Oh, TI to TI plus 1. I'm confused. Holy shit. Cities on the map are connected by the number of roads. Okay, I guess we can draw. Oh, wait, well, fuck me. Okay, so this is incorrect. From city 0 to city 1. From city 1 to city 2. Right? The number of roads between each city is an array. City 0 is the starting location. The number of roads from city 0 to city 1 is the first value in the array. From city 1 to city 2 is the second, and so on. And we pass order from city 0 to the last city in the list. So this is 1 plus 1, 2, 3. No, it's not. This is 1 plus 2 plus 3. So if this was 2, you would have 1, 2, 3, 4, 5, 6. This is it just a sum? No fucking way, it's a sum. That's stupid. After all that. Can't be. I think it has to be. What? Int integer array. There's no fucking way, right? Oh. One times 3. Oh, why isn't there a product function? Prod? That has to be a product function, right? Okay. Nice. Okay. That was kind of annoying. I thought that would be actually a fun challenge. Okay. I'm gonna head out. We will continue on this tomorrow. And the day after, until it's perfect. Alright, good night.